everyone. My name is Gerald Piranya Naingi, together with my colleagues, Colpatrick Samantina, Hermita Patalinghog, Claire Lonyo. And today, we're gonna talk about the Module 7, the unequal heating of Earth. But before we proceed to the discussion, I'm going to read the objectives because the students are expected to identify the five layers of atmosphere, discuss the factor that cause unequal heating of Earth, describe how Earth tilts affect the seasonal difference in temperature. Atmosphere. The atmosphere contains all the air in Earth's system. Yes, and we have five major gases. This is the nitrogen, oxygen, carbon dioxide, argon, and ozone. Nitrogen has almost 78% and oxygen for 21%, carbon dioxide of 0.03% and zero point 0.9 for argon and ozone layer. Those are the major gases that has been found on Earth atmosphere or in the atmosphere. And the atmosphere is a thin layer that surrounds the Earth. Yes, because this is the stand as the blanket of air constantly shield the surface and its inhabitants from the sun dangerous ultraviolet radiant energy as well as from the onslaught of material from interplanetary space. And our planet retains an atmosphere when the gravity is great and the temperature of the atmosphere is low, because the air molecules and everything else in the atmospheres are held towards the earth by the gravity. And these gravitational attractions between the earth and the atmosphere is greatest near the surface, which is makes the density of air is greatest near the earth's surface and decrease with increasing altitude. This makes the air compress these bounce molecules closer together. If there are more air above, there is a certain level that will increase or decrease. Composition of the atmosphere. The atmosphere is divided into five layers. It is the thickest near the surface and thins out with the height until it eventually merges with space. And those five layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And the Earth atmosphere extends outwards. It is about 1,000 kilometers, where its transitions to the interplanetary space, its upper limit becomes the thinner and thinner, then eventually merging within the empty space. Almost 99 of the mass of the atom is located within the first 40 kilometers, and this thin blanket helps us to shield from the ultraviolet radiant energy from the sun or the star. Now I'm going to introduce to you the five layers of Earth atmosphere. The troposphere first. The inhabitants of our planet live in the tropospheres. It begins at the Earth's surface and extends up to 6 to 20 kilometers. Because troposphere all water occurs within this layer. Air is warmest and the bottom of the troposphere near ground level or higher up it gets colder. Air pressure and the density of the air also less at high altitude of this layer. Now let's moving on to the stratosphere. The stratosphere is the atmosphere about 10 kilometers is called the stratosphere. This layer extends from the tropos up to 50 kilometers above the Earth's surface. Because the stratosphere is very dry air that contains little water vapor, those few clouds are found in this layer. Almost all clouds occur in this lower, more humid troposphere stratosphere. This is the path of the stratosphere occurs at 50-kilometer altitude. The altitude of the bottom of the stratosphere varies within the latitude and with the seasons occurring between about 8 and 16 kilometers. Now we're on the mesosphere. The mesosphere extends from the stratosphere to about 50 miles above the Earth. And also, the facts about mesosphere is the top of the mesosphere is coldest part of the Earth atmosphere. The temperature in the mesosphere is around negative 90 degrees Celsius, or what we call negative 130 degree Fahrenheit. And the mesosphere is the boundary between mesosphere and this next layer. Now, let's moving on to the thermosphere. The thermosphere is a region above the top of mesosphere that extends from the mesopause to 690 kilometers above the Earth's surface. Because they believe that air density on this layer is so low in the layer that most of the thermosphere is what others normally talk about or think as the outer space. Space shuttles and international space both orbit Earth within the thermosphere. That is thermosphere. And now we were moving on to the next, which is the exosphere. And the last one of the 5 layers of the Earth atmosphere is the exosphere. The exosphere is the outer layer of the Earth atmosphere and extends from the thermopause to about 10,000 kilometers above the Earth. And also, in this layer, atoms and molecules escape into space and satellites orbit on Earth. And also, the exosphere and thermosphere boundaries is called thermopause. And this is the end of the 5 layers of the Earth atmosphere.
Good morning, everyone. My topic is temperature differences, and seasons. So let's talk first about temperature. What is temperature, by the way? We all know that temperature is the scale of the warmth or coldness of an object, and temperature also has a significant impact on how the weather develops and how different organisms go through their life cycles, and how the water level is maintained. A few degrees of temperature change can completely destabilize an ecosystem. The majority of plants have a range of ideal temperature. What does this mean? So this only means that it says that the temperature has a significant impact on how the weather develops, how different organisms go through their life cycles. For example, the processes the processes of our natural environment. So temperature affects the natural process of the environment in the sense that, for example, the process of photosynthesis. So because of high temperature or too much hotness of the Earth's surface, the plants will not survive. In result, the photosynthesis might not be successful. Another, the water level. So why does it it talks about water level? It is because of if, for example, in the countries that has iceberg, so because of too much temperature, the ice will melt. In result, or in effect, the water level or the sea level will increase. Next, a few degrees of temperature change can completely destabilize an ecosystem. So the example for this is the forest fire. Too much temperature can create the fire in the forests. And for that, the entire or the habitat, or not just the habitat but the organisms itself, will be affected, or must much worse. They can die. They will die. So in that, because of that, the entire ecosystem will be destabilized. The majority of plants have a range of ideal temperature. So there are plants that is uh, high temperature resistance, but also there are plants that cannot live with high temperature. Next is the temperature differences. So, uh, in temperature differences, uh, a temperature change occurs when temperature is increased or decreased by the flow of heat. This shifts chemical equilibria towards the products or reactants, which can be determined by studying eh, the reaction and deciding whether it is endothermic or exothermic. So, from the word temperature and differences, this means the pagkakaiba ng temperature. Uh, the temperature change occurs when temperature is increased or decreased by the flow of heat. What is the flow of heat, by the way? Flow of heat is the movement of the heat in the Earth's surface, not just in the Earth's surface but also in the atmosphere. There is heat in the atmosphere also. But let's talk in the Earth's surface. So the movement of the heat in the Earth's surface, this occurs, by the way, because the natural environment tries to balance the release or the hotness or coldness of the Earth's surface. For example, that particular area has high temperature, then the other has low. So the natural environment, our environment, the nature, will bring or will share the heat from that particular area into the cold one, trying to have a balance. So that is why flow of heat occur. Earth surface temperature. Average temperature on Earth lies somewhere around 57 degrees Fahrenheit or 13.9 degrees Celsius. Average across land and ocean in the 2021 surface temperature was in 1.51 degrees Fahrenheit and 0.84 degrees in Celsius, warmer than the 20th century average of 57.0 degrees Fahrenheit or 13.9 degrees in Celsius, and 1.87 degrees Fahrenheit or 1.04 degrees Celsius, warmer than the pre-industrial period. So this we have talked about the how temperature affects the lifestyle or the life cycle of the environment and the processes of the natural environment. So now it says here that somewhere around 57 degrees, the average temperature is in 57 degrees Fahrenheit or 13.9 degrees Celsius. So I've said earlier that the heat or temperature affects the processes or the cycles of the natural environment. So for example, the photosynthesis. So if the average heat or the average temperature of the earth go much higher than 57 degrees Celsius, it can disrupt or interrupt the process of the photosynthesis. So when it, for example, it becomes 50, higher than 57, let's say 62 or around 60 or more, or 59 or 58, so that it can affect, or it uh, it can make the process unsuccessful. So next is the solar constant. The solar constant is a measurement of the solar electromagnetic radiation available in meters squared of Earth's distance from the Sun. The solar constant is used to quantify the rate at which energy is received upon solar unit surface, such as a solar panel. So solar constant, it says that solar constant is a measurement of it is a measurement of the solar electromagnetic radiation uh, available in meters squared at Earth's distance from the Sun. So it means that what this means that when it says that it is a meter squared at Earth's distance from the Sun, it means that the measurement is twice as the distance of the Earth from the Sun. Next is the latitude. Latitude is the measurement of distance north or south of the equator. It is measured with 180 imaginary lines that from circles around the Earth east to west, parallel to the equator. These lines are known as parallels. A circle of latitude is an imaginary ring linking all points sharing the parallel. So why does latitude contributes in the uneven or the unequal heating of the Earth? So what is latitude, by the way? So the latitude is the when you see the globe. So the one that circles it, the line that circles the globe is what we call the parallel. The latitude. So it is placed in the middle of the Earth, from between north and south. So it circles the Earth. So why does it what it considered why does it consider as a factor in the unequal heating of Earth? Because the places in the latitude places near the latitude have high or hotter temperature than the places far from the latitude. So question, how does the altitude of a place affects the temperature? So it is very basic that the higher the altitude, the colder the place, no? Like for example the mountains, or like for example here in the Philippines in Baguio City. So because Baguio City has higher altitude, so it is more colder. So and vice versa, when you have low altitude, or when your place has low altitude, so it is more hotter than the other one that have high altitude. So the seasons, my last topic. Seasons takes a year for the Earth to orbit around the Sun. As the Earth moves, the angles at which sunlight strikes different places on the Earth at the same time of days changes, because the Earth is tilted. When a particular location is tilted towards the Sun, warmer temperature occur. When the same place is tilted away from the Sun, colder temperature occur. So it is very understandable about the season. It says that the day or time changes because the Earth is tilted. So when a particular location is tilted towards the Sun, warmer temperature occurs. So it's very understandable, no? It is very easy to understand that uh, we have different temperature because our Earth is tilted. It is by its orbit through the sun. Now, so when the it says that when a particular location is tilted towards the sun, warmer temperature occurs. Then vice versa, when the same place is tilted away from the sun. So it only means that colder temperature will occur.
The Earth revolves on its tilted axis, which means that any given time, half of the Earth is experiencing day and the other half is experiencing darkness. Because it is a spherical, the equator, which is the widest point, hits more evenly than the poles. The Earth is made up of more than 70% water, and the water and land heat and cool at different rates, resulting in an even heating. The Earth, like the Sun, is a sphere. The center of the Earth receives more direct sunlight than the poles as the Earth orbits the Sun. The tilt of the Earth exacerbates this. Because the center of the Earth receives more sunlight, it is continuously hotter than the rest of the planet. Heat causes air to ascend. It produces low pressure zones that suck in air from the other areas, resulting in wind. All of the known climate and weather patterns are caused by the heating and cooling of the Earth's air.
Hello everyone, good day. I am Rona May Tapatalinghog and I'm going to discuss about the creation of fronts. But before that, let us discuss first what does fronts is. So, a front is a weather system that is the boundary separating of two different types of air. And each air mass has unique temperature and humidity characteristics. So when a front passes over an area, it means a change in the weather. Many fronts cause weather events such as thunderstorm, rains, gusty winds, and tornadoes. Creation of fronts. When two contrasting air masses converge in the formation, circulation, they spread horizontally along the axis of outflow or dilution. In such situation, the creation of front depends on the angle between the axis of outflow and isotherms. So, fronts develop when two air masses collide at Earth's surface. At the frontal boundaries, air masses interact with each other to form weather events like rain, winds, and thunderstorms. So, the process of a formation of a front is called a frontgenesis, which is a war between two air masses. So there are four different types of fronts, and the weather associated with them varies. The four different types of fronts are cold fronts, warm fronts, stationary fronts, and occluded fronts. So let us discuss first what is warm fronts. Warm fronts is that gently sloping frontal surface along which warm and light air becomes active and aggressive and rises slowly over cold and dense air. The average slope of warm fronts in middle latitudes range between 1 is to 100 to 1 is to 400. So a warm front is the boundary along a warm air mass that is pushing out a cold air mass. A warm front forms when two air mass pushes into a colder air mass. Warm fronts often bring stormy weather as the warm air mass at the surface rises above the cold air mass, making clouds and storms. Warm fronts move more slowly than cold fronts because it is more difficult for the warm air to push the cold, dense air across the Earth's surface. So next is cold front. Cold front is that sloping frontal surface along which cold air becomes active and aggressive and invades the warm air territory, and being denser remains at the ground but forcibly uplifts the warm and light air. So a cold front forms when a cold air mass pushes into a warm air mass. Cold fronts can produce dramatic change in the weather. They move fast, up to twice as fast as a warm front. As a cold front moves into an area, the heavier, more dense cool air pushes under the lighter, less dense warm air, causing it to rise up into the troposphere. As the cold front passes, winds become gusty. There is a sudden drop in temperature and also heavy rain, sometimes with hail, thunder, and lightning. But after a cold front moves through the area, you may notice that the temperature is cooler, the rain has stopped, and the skies are clear. Next is occluded front. Occluded front is formed when cold front overtakes warm front and warm air is completely displaced from the ground surface. So, sometimes a cold front follows right behind a warm front. A warm air mass pushes into a colder air mass, which is the warm front, and then another cold air mass pushes into the warm air mass, which is the cold front. Because cold fronts move faster, the cold front is likely to overtake the warm front. This is known as an occluded front. At an occluded front, the cold air mass from the cold front meets the cool air that was ahead of the warm front. The warm air rises as their air masses come together. Occluded fronts usually form around areas of low atmospheric pressure. So the last one is stationary front. Stationary front is formed when two contrasting air masses converge in such a way that they become parallel to each other and there is no ascent of air. In fact, the surface position of stationary front does not move either forward or backward. A stationary front forms when a cold front or warm front stop moving. This happens when two masses of air pushing against each other, but neither is powerful enough to move the other. Winds blowing parallel to the front instead of perpendicular can help it stay in place. A stationary front may stay put for days. If the wind direction changes, the front will start moving again, becoming either a cold or warm front, or the front may break apart. Because a stationary front marks the boundary between two air masses. There are often differences in air temperature and wind on opposite sides of it. The weather is often cloudy along a stationary front, and rain or snow often falls, especially if the front is in an area of low atmospheric pressure.
So, here we go again. So, I'm going to discuss the Earth energy balance and heating of the atmosphere. Earth energy balance describes how the incoming energy from the sun is used and returned to the space. If incoming and outgoing energy are in balance, the Earth's temperature remains constant. Because according to the www.weather.gov website that the Earth atmosphere energy balance is achieved as the energy received from the sun balance the energy lost by the Earth back into space. In this way, the Earth maintains the stable average temperature and therefore the stable climate well committed. So, let's proceed to the two kinds of radiations, which is the shortwave radiation and the longwave radiation. So, here's the two radiation, which is the shortwave radiation and the longwave radiation. The shortwave radiation is 100% of energy entering the Earth's atmosphere comes from the sun. So, shortwave radiation is the radiant energy produced by the sun with a wavelength of ranging from infrared through the visible to ultraviolet. Shortwave radiation is therefore exclusively associated with the daylight hours for the particular location on Earth's surface. And for the long wave radiation, have a 50% of incoming energy is absorbed by the Earth's surface, for example, the land and the oceans. Because the long wave radiation is from warm upper atmosphere along with a small amount from the Earth's surface, radiates out to the space. Most of the emanated long wave radiation warms to the lower atmosphere, which is storing warm our planet Earth or the planet's surface. That's all, and thank you.
Differentiation between revolution and rotation of the Earth. The Earth axis is tilted is the most important fact that we have seasons. Because the Earth axis is tilted, the southern hemisphere tilts away from the sun in winter, getting only indirect energy from the sun. So, what are the difference between Earth rotation and Earth revolution? So, the Earth rotation. The Earth spins as the orbit around the sun, and the sun light up one half of the Earth and the other half is shadow. The spinning of the Earth around its axis is called rotation. So when we say rotation, it refers to an object's spinning motion about its own axis. This means the Earth is tilted on its axis, and because of this tilt, the northern and southern hemisphere lean in direction away from the sun. Earth rotates, producing 24 hours or 1 day. Next is the Earth revolution. The Earth revolves around the sun. The Earth revolution around the sun and the tilts of its rotational axis result in the season. So the movement of the Earth around the sun in a fixed path is called a revolution. When we say revolution, it refers to the object's orbital motion around another object. So the Earth completes one revolution around the sun in 1 year, or precisely in 365 days. So the difference between Earth rotation and Earth revolution is that when we see Earth rotation, Earth rotates on its own axis, and the Earth takes 24 hours to complete a rotation with respect to the sun. Whereas Earth revolution, the Earth revolves around the sun, and the Earth takes 1 year or 365 days for one complete revolution around the sun. The transfer of energy. The sunlight is more intense in equator than at the poles, creating a marked differences in temperature. The two most important mechanisms that transfer heat energy on our planet and ocean current. When we say energy, it is the ability to do work, or in more simple terms, energy makes things happen. Energy transfer refers to the movement of energy from one place to another. The sun rays are strongest in the equator because sun rays hit the Earth's surface at a higher angle at the equator, where UV rays must travel the shortest distance through the atmosphere. Then even global heat distribution give rise to convection current in the atmosphere that attempt to equalize heat distribution. In short terms, hot air in the tropical region rises and moves north and south as upper air wind. So in its most simple form, we can imagine that heated air at the equator rises up and spreads north and south towards the poles. It gradually cools, sinks down in the polar regions, and then flows across the Earth's surface to the equator. Global winds drag on the water surface, causing it to improve and build up in the direction that the wind is blowing. However, it helps to distribute the hot or warm air on Earth and even the cold water. So the global winds that drive surface currents are affected by a number of things, one of which is the rotation of the Earth.
So these are the effects. First is wind. Wind is caused by the uneven heating of the earth. As a result, the air absorbs varying amounts of heat, making it warm in some regions and chilly in others. The particles in air spreads out as it warms. In other words, When heated, air expands. As a result, the air becomes lighter or less dense and rises. Second is land and water, because land heats quicker than water. Solar heating at the Earth's surface is uneven, causing air to warm, expand, and rise over land while cooling and sinking over colder water surfaces. Because of these variances, air expands where it is hot and contracts where it is cold.